Hi students, in this video we're going to explain how to calculate the constant of the spring using a simulation. As you can see, I have a screenshot of the simulation here. In this simulation we have this spring that you see over here, and then we can control the mass of the bob, right, that you have hanging from the spring with this controller over here. And you can also control the spring strength, right, using this other control. You will have also the option to check on a stretched length, resting position, and the distance from the unstretched length to the resting position will be the value of the elongation that you have for your spring. You can measure that value of elongation of the spring due to the action of the mass that is hanging using this ruler, right? So what are you going to do? You're gonna start increasing the mass, right? 50, 100, 150 grams, right? And then you will be measuring with the ruler the value of y, or the value of the elongation of the spring due to, the mass that is hanging. With that data, you will just complete the following table. So as you can see here, you have different values of mass in kilograms, right? So using the formula you see here of elastic force, that say that elastic force is equal to mass times gravity, you can calculate the elastic force in the third column. So it's basically to multiply the value of mass, right, of the body hanging from the spring times the acceleration of gravity, and that is going to give you the elastic force. You also have in this column values of y, or elongation, that you have measured with the ruler, right? So you will complete these two columns of the table easily, and then after that you will be able to calculate the constant of the spring dividing the elastic force by the elongation. At the end, once you have calculated all the values of constant of the spring for the different values of mass here, you will calculate the average value of the constant of the spring. In this case, I got 6.08 newtons per meter. Then later they ask you to determine the percentage of error of the constant of the spring, assuming that the acceptable value of the constant of the spring is 8.50 newtons per meter. I just did the determination of the percentage of error, and I found that the percentage of error in my case was close to 28.5%, which is a very high percentage of error. To be honest, I suspect that this value of constant of the spring that they are asking to assume is not correct. I believe really, that this is probably lower, but in the simulation we have no way to determine what is the exact value of constant of the spring that we are using. So after that, you're going to get the columns of elastic force and the column of the elongation of the spring, and you will make a graph of elongation versus elastic force. You will plot the points, you will find the line that better fit the data points, and you will ask the software, in this case Microsoft Excel, just to put the equation, that describe the line that better fit the data points. Now, since elastic force can be also determined as minus the value of the constant of the spring times the elongation, if the elastic force is just here the dependent variable, and y, the elongation, is the independent variable, we can determine k, just equal to the value of the slope. The value of a slope I got in this case was 5.99 newtons per meter, and after that I have to compare the average value of the constant of the spring that I found in the previous slide versus the experimental value of the constant of the spring. To do it, I just decide to find the percentage of difference instead of using percentage of error. And then what I determined, is that the percentage of difference between these two values, 6.08 and 5.99, is approximately 1.49%. So thank you so much for your attention. I really hope you know that this video was interesting and useful for you to understand how to find the constant of the spring. And please subscribe to my channel and support my work. Thank you so much for your attention.